Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy, and I'm Jeetendra Dixit. So before we begin, let me just check the sound. Alright, so in this session we'll continue circles and also before we begin, let me tell you about Unacademy subscription. So as you know, Unacademy this is my profile. So I'll start with my introduction. I did my BTech from IIT Kanpur, and I've been mentoring IIT-JEE aspirants for last 11 years. So in this session, as I told you, we will continue circles, and this is the fifth session of circles. So we'll discuss theory of circles further. But before that, let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform, and if you are preparing for IIT-JEE, then you can have two types of subscriptions on Unacademy. One is Plus subscription and another is Iconic subscription. In Plus subscription, you get access to daily live classes of all the educators who are teaching for IIT-JEE. You can watch their live session as well as recorded sessions. You can follow educator of your choice. You have complete freedom. All the live tests and quizzes will also be accessible to you. Now, and the courses which I'm talking about are really structured courses. That means everything is pre-planned. You can see the schedule of all the upcoming sessions in well advance. Now, these are the subscription charges. You can subscribe for 1 month. Yeah, so you can subscribe for 1 month, 3 months, 6 months, 12 and 24 months respectively. And the next is Iconic subscription, and also yes, you get 10% left inside. You can see the price list, which is without discount, and after 10% discount you can see the price list on the right hand side. So you can use the code JEET1. This is my referral code. You can use this code and get instant 10% discount when you are taking the subscription. All right, now this is the Iconic subscription, in which you get all the benefits of Plus. So whatever, hello Raghav. So you get all the benefits of Plus, and apart from that, 1 minute, sorry. Yeah, and apart from that, you'll get a personal coach who will guide you throughout your preparation for IIT-JEE. Your tests will be done, test analysis will be done in a personalized manner, personalized feedback will be given to you, improving your time management and exam approach. All right. And your study planner will be customized, bi-weekly reviews will be given to you. So you'll get all these benefits in Iconic subscription. These are the charges for Iconic subscription. You can subscribe for 6 months, 12 months and 24 months. And this is Unacademy's learning app, which you can download from Play Store. And after downloading it, you can start attending special free classes, which you can watch without paying anything, without having any subscription. All right, and now this is the information about the 2 batches which are starting for JEE Main and Advanced 2023. Spark batch for class 11th. So you can see the educators who are going to take this batch. It is starting in December 2021. And second is this is JEE Main and Advanced. Okay. This is another batch. You can see the educators list in this also. All right, so now we will begin the session, today's session. Hi Jia, hello Raghav. So how are you guys? What were we doing last time? We finished circles. Okay, we are supposed to do the equation of tangent to a curve at a given point. Okay, so now let's begin from there. Tangent, equation of tangent to S is equal to 0 at point P Px1 y1, okay, where P lies on the curve. P lies on the curve. That means P is point of contact, okay. So S can be any curve, okay. This is a general method. S can be any curve like parabola, ellipse, and hyperbola. So we are writing this, a point is given on the curve. This is x1, y1. This is point P, okay. This point is point P. And we need to write the equation of tangent to this curve at point P, all right. We haven't done this. We did equation of tangent in slope form. We did tangents from an external point. Now the point is given on the curve and we need to write the equation of tangent. All right. So now there's a direct formula. First, let me write the S. So you know here S is ax square plus 2hxy. I'm taking the general curve plus by square plus 2gx plus 2fy plus c. Okay, this is S. So equation of tangent is given by t is equal to 0. All right, simple. T is equal to 0. So this t is equal to 0. You know what is t? T is a when x square is replaced by xx1. 2hxy is replaced by xy1 plus yx1 plus by square. So y square is replaced by yy1 plus 2x is replaced by x plus x1. And 2y is replaced by y plus y1 plus c. Okay, so this is equal to 0. This is the equation of tangent at a given point. So directly you can use this. We can prove it using the formula of using calculus. Basically we need to find dy by dx for this curve, and then we can write the equation of tangent. First we need to write dy by dx, and then we can write y minus y1 is equal to, so we have used actually this formula, y minus y1 is equal to dy by dx, which we can find from the given equation of curve x minus x1. Okay, so just put dy by dx and simplify, you'll get this. So I'm directly writing the result. Is this okay, Gia? We need to remember this directly. T is equal to 0 represents the equation of tangent. So we will see the application of this first. Suppose, for example, let's see one example. A curve is given x square plus y square is equal to 4, and a point is 1 comma minus root 3. Okay, tangent at 1 comma minus root 3. Can you see 1 comma minus root 3 is lying on this circle? Are you there, Gia? Raghav, are you guys there? So 1 comma minus root 3 is like this point. We need to write the tangent. So equation of tangent is, we know, is t is equal to 0 because point is on the circle, point is on the curve. So t is equal to 0 is equation of tangent, and only one tangent can be drawn. So it is going to be, yes, it is x into x1, so x into 1 plus y into y1, so y1 is minus root 3. I think Gia is disconnected. Is equal to 0. So you'll get this, x minus root 3y is equal to 4. This is the equation of tangent. All right. So you already know it, Raghava. So let's move on to another point. Common tangent. Common tangent to, okay, common tangent to two circles. So first of all, we know position. Let's see the position of two circles. So first case is this position, then we will start position of two circles. We are doing this first, position of two circles. Root 1 plus m square what? For common tangent. Position of two circles we are doing, that means whether circles Okay, I'll explain it again. See, I was saying that this is a 2-degree journal curve, S is equal to 0, all right? And a point is given, a point is x1, y1, which lies on this curve, And we need to write a tangent at that point. Initially, before this, what we did was, we were doing the tangents from an external point, right? Now we are finding the tangent at a point which is on the curve, and curve equation of curve is given and point is given. So the equation of curve is t is equal to 0, okay? T is equal to 0, and t, we know what is t, okay? So I have written for this general curve, I have written t here. So if x1, y1 is on the curve, then this tangent, equation of tangent is t is equal to 0, and this is t. All right. And how did we get this formula? So that is using calculus. Okay. For any curve, you'll learn this method in calculus to find the equation of tangent of any curve, not only 2-degree curves. This formula is only for 2-degree curves. Okay. This formula t is equal to 0 only for 2-degree curves. Okay. Because we are actually using this method, y minus y1 is equal to mx minus x1. And what is m? Slope of tangent at a given point is nothing but dy by dx at that point, right? So first we'll find dy by dx, okay, for this curve, s is equal to 0 for this curve, okay? You can find dy by dx for this curve. And then you can apply this formula, y minus y1 is equal to dy by dx, x minus x1. And after simplifying, it becomes t actually, right? And we know the significance of t. It appears in many formulae. So now we will memorize this. We actually, if I ask you to write the tangent of y is equal to x cube at some point, say 1, 1, then you'll have to do it using calculus. You don't know any formula for that. Are you understanding, Jia? Or shall I give you one, right? Shall I write one example? Example, see the method. Let me tell you the method. If you have this curve y is equal to x cube, okay, and we need to write tangent to this at 1, 1. You know 1, 1 is lying on this curve. So how would we do it? We'll do dy by dx. First we'll find dy by dx. So dy by dx is 3x square, okay. Then at x is equal to 1 you need, so it is 3. So we have got the slope of tangent. You have got the slope of tangent, it is 3x, okay, and the point is given 1, 1. So now it's simple. You need to write the equation of line, y minus 1 is equal to slope and x minus 1. So this is the tangent, y is equal to 3x minus 3 plus 1, so minus 2, okay. This is the equation of tangent. But second example, if you need to find the equation of tangent to y is equal to x square at x is equal to 1, or you mean 1, 1. Then you can use two methods. You can use calculus, you can use this direct t is equal to 0, because this is a 2-degree curve, right? This is a 2-degree curve, so you can use this method. This point lies on this curve, so you can use t is equal to 0, which will give you, so what we write, y is replaced by y plus y1 by 2, and x square is replaced by x1. So using that, you'll get y plus 1 is equal to 2 times of x into 1. So finally you get y is equal to 2x minus 1, okay. This is the equation of tangent using t is equal to 0. But if you use calculus, then yes, you need to find dy by dx. So that is 2x, okay. And then dy by dx at x is equal to 1 is nothing but 2. Then you can write the equation of tangent, y minus 1 is equal to 2 times of x minus 1. So you'll get this y is equal to 2x minus 1. Again, you're getting the same tangent, same equation, all right. You can see that. So using calculus, using this t is equal to 0. So what we did actually, we used this calculus. I think now you are able to connect, right? Now what we did, because we know all our conics are represented by one equation, right? All parabola, ellipse, hyperbola, okay, their general equation is given by this, s is equal to 0, right? So why not we should learn or memorize one formula for all the curves, okay? If we memorize a formula for this general curve, then we can apply it for any 2-degree curve, right? Whether x square is missing, whether xy term is missing, whether x wala term is missing, right? It doesn't matter. So what we did, we used this calculus. First, we assumed the point on this curve x1, y1. At this point, first we found dy by dx, all right? Dy by dx at x1, y1, okay? And then we applied this formula, y minus y1 is equal to dy by dx x minus x1, and ultimately we saw, oh, it's t actually. The result which is coming out to be is nothing but t. We know this expression t, okay? This will be used in many formulae. So now it is relatable also. It is, I mean, easy to memorize because the t is a very important term and we use it in many formulas. So I hope now I'm making sense, right? So now we'll remember that if point is given on the curve and we need to write the equation of tangent, there will be only one tangent and the equation of that tangent is going to be t is equal to 0. But if point is not on the curve, then you write t is equal to 0, then again you'll get a line, but that will not be tangent, okay? That will be something else. Because t is equal to 0 is always a line with respect to any point, to any curve. T is equal to 0 will always be a line. But if that point lies on the curve, then it becomes the tangent. So now I think I'm clear, okay? So you can apply this method to find the tangent. So it is very simple. Now what we are doing is, so this portion was very easy, okay? Just you need to learn this formula, t is equal to 0. Nothing much to do in this. We will directly use it, okay? And this formula is applicable everywhere, parabola, ellipse, hyperbola, everywhere, okay? I mean, in every conic. Now we are finding the common tangent of common tangent of two circles. So first, let's see the positions of two circles. If two circles are positioned like this, suppose one circle is completely outside the other, how would you come to know? So, you know, this is C1, center of first circle. This is C2, center of another circle. So we can find the distance between centers easily. We know the coordinates, so how to write the coordinates of centers. So, and say the radius of this circle is R1 and radius of this circle is R2. So if R1 plus R2 is less than C1 plus C2, okay? R1 plus R2 is less than C1. Sorry. What am I writing? R1 plus R2 is less than C1 C2. R1 plus R2 is less than C1 C2. Or you can say C1 C2 is greater than R1 plus R2, okay? C1 C2 is greater than R1 plus R2. That means one circle is completely outside the other. And in this case, we'll add number of tangents. Number of tangents in this case will be 4, okay? 4. Sometimes they ask how many tangents these two circles will have. So that means you need to check the positions of these two circles, whether one circle is outside the other or they are touching each other. These are the scenarios. Circles might touch each other externally. This means they are touching each other externally. Then this is called intersecting wala case. Okay, they are intersecting, and this is very important case. The next case is this one, when one circle is completely inside the other but touching it. I mean, they touch each other internally. And the last case is when circle is completely inside the other, okay? I mean, like this one. Yeah. So I'll write the conditions and number of tangents. In this case, you know, the condition is going to be R1 plus R2 is equal to C1 C2. We already know that when circles touch each other externally, and number of tangents is going to be 3. In this case, you know, this one is very important. Can you guys tell me the condition for this intersecting third case? Can you tell me the condition for third case? This is very important. That's why I'm asking this. What is the condition on R1, R2 and C1, C2? Write it. Raghav. Yeah, this we did in the first class, but not the third one. What is the condition for third one? Tell me fast. Condition for intersecting circles. What is the condition for intersecting circles? Okay, I'll give you one question and then I'll come back, okay? So the question is this, I'll come back to that theory. I'm giving you a simple question to analyze. Find the value of R if x square plus y square is equal to 9 and x minus 3 the whole square plus y plus 4 the whole square is equal to R square intersect each other at two distinct points. Okay, so can you guys tell me the condition for values of R? Okay, now do it. Now do it for this question. Okay, find the value of R. I'll give you two questions actually. Then I'll go back to that theory part. Okay, no problem. Yeah, so now let's do these questions. If two circles, Raga, have you got the answer? So this is one of the circle whose center is at 0, 0 and radius is 3, okay? The another circle whose center is at 3, comma minus 4, somewhere here. Let's take this 3, comma minus 4. R is greater than 2. R is greater than 2, okay, that is all right. But you forgot one, inequality at the other side. So if R is equal to 2, they are going to touch each other, right? If R is equal to 2, they are going to touch each other. This is the case when R is equal to 2. When R is greater than 2, they are going to intersect each other. Very nice. Because this total distance OC is basically 5, right? And this radius of this circle is 3. So this will be actually 2. You know? So in case of 2, they are going to touch each other. And when R is more than 2, they are going to intersect each other. But if you keep increasing R, then there will be one case then when these two circles will touch each other internally also, right? You can see that is the case. Yeah? And after that, what will happen? This white wala circle will be completely inside this yellow wala circle, right? Can you see that? So that is going to be, that means they will not intersect each other. So this is the limiting case, okay? What is the limiting case? This R should be greater than 2, but it should be less than what? It should be less than 5 plus 3, 8, okay? You know 5 plus 3, how did I get 5 plus 3? Distance between centers is 5 plus the radius of white wala circle, okay? This is 5 and plus 3, this is 3, okay? This is 3 and this is 5, All right, so less than 8. So that was the condition I was talking about there. There will be two conditions in this case. R1 plus R2, that should be less than, C1 plus C2, distance between centers, C1 plus C2 should be less than R1 plus R2 and greater than R1 minus R2 mod. All right, this R1 minus R2. So there is a lower limit also, okay, in this case. Because the next case, in this case, when it becomes equal to R1, R2, C1, C2, I'm sorry, C1, this is not C1 plus C2, this is C1, C2, distance between centers, C1, C2. Now, in this case, when circles, fourth case, when circles touch, in this case, there will be only two tangents, and when circles touch each other internally, there will be only one tangent, and then C1, C2 is equal to R1 minus R2 mod, right? And this is the case when R1 minus R2 mod is greater than C1, C2. You know? So you can see C1, if I plot this number line, in this case there will be 0 tangents, right? In this case there will be only one tangent. So you can see number of tangents are decreasing continuously. See, this is the number line. I'm again mentioning this thing. This is a number R1 minus R2 mod. This is 0. This is a number R1 plus R2, okay? So if your C1, C2 is here, C1, C2, this is the first case, okay? When C1, C2 is greater than R1 plus R2. If your C1, C2 is here, exactly equal to this is the second case, okay? Second case, that means C1, C2 is equal to R1 plus R2. When your C1, C2 lies, this is the third case, when C1, C2 lies in this interval, okay? In this interval. This is the third case, okay? Intersecting. This is the fourth case. This is the fourth case when C1, C2 is equal to R1 minus R2 mod. That means it will touch each other internally. So can you see C1, C2 is decreasing. Distance between centers is decreasing and is decreasing. Circles then start touching each other, then they will intersect, and then further they'll one circle will be completely inside the other and it will touch internally, and then it will be completely inside and non-intersecting, okay, when C1, C2 comes in this interval. So I hope now you can relate this number line, all right? All right. So the first case is where there are 4 tangents. So first case means C1, C2 is greater than R1 plus R2. All right. So non-intersecting circles, and one is completely outside the other. So S1 is first circle, which is x square plus y square plus 2 g1x plus 2 f1y plus c1 is equal to 0. And S2 is the another circle, which is x square plus y square plus 2 g2x plus 2 f2y plus c2 is equal to 0. All right. No, I think it will take 2 more sessions at least. There's family of circles and many things actually. Okay, common chords and radical axis is there. It will take 2-3 sessions. Okay, let's finish common tangents first today. So you know how to find the common tangents in this case? If I cover the theory completely, then it will take some time. 2-3 sessions. Okay. So can you see? These are two circles. This is say C1 center of first circle. This is C2 center of another circle. This tangent is called, these two tangents, okay? This tangent is called direct common tangent. So there will be 2 direct common tangents. One is this and the other is this. So first we are finding the equations of direct common tangents, okay? Then we will do transverse common tangent. Transverse means like this, which will cross. This is called transverse, this one. So first we are finding the equation of direct common tangents, okay? These are direct common tangents and these are transverse common tangent, okay? So how to find the equation of direct common tangents? Can you tell me, Raghav? This is point P. This is C1. Let's draw a perpendicular. This is R2. This is R1. Right? We can write R1, R2. We can write C1, C2. C1 is minus G1 minus F1. C2 is minus G2 minus F2. Right? Yeah. So tell me, how to start? Pythagoras. No, not Pythagoras. What Pythagoras? We are not finding the length of something. We need to find the equation of something. Equation of tangent. See, first we are going to find this point P, coordinates of this point. Okay. Let's say this point is x1, y1. Okay. X1, y1. So I'll tell you the procedure. Just listen to me. Okay. I'll tell you the complete procedure. So this, suppose this point is A and this point is B. So triangle PAC2 is similar to triangle PBC1, right? If they are similar, that means PC2 upon PC2, this distance upon PC1, okay, PC1 can be written as R2 upon R1. That means PC2 upon PC1 we have got. That means P divides, and P is collinear with C1 and C2, right? I think this point is clear. So that means P divides C1 and C2 externally in the ratio of R1 is to R2, all right? So P divides C1 and C2 externally in the ratio of R1 is to R2. Okay. So now we can write, you can use external division formula. So you'll write x1 is equal to, what will be x1? R1 into minus G2, R1 into minus G2, minus, in between there's, in external division formula there's a minus sign between the two terms. R2 into minus G1, right? Divided by R1 minus R2. This is the x coordinate, and y1, y coordinate is going to be R1 into minus F2 minus R2 into minus F1 divided by R1 minus R2. So we have got this point, right? So using external division formula, first of all, you get this point easily. Okay. Yeah. And after getting this, now what to do? So this is the first step. Okay. The first we are going to understand that P divides C1 and C2 in the ratio of R1 is to R2. Okay. We'll remember this. And we'll directly apply the formula. So directly we need to use this formula, formula of external division, to find the coordinates of point P. Okay, this is our first step. This is our first step to get the point of intersection of tangents. After this, what we need to do? So see, now there's a point. Now only draw one circle. Take any circles, S1 or S2, doesn't matter. I have drawn one of the circle. Okay, and this is the point. So this you need to draw. You need to find, basically, now what is the question? Your question is to find the equation of tangent to S1 from P, from point P. So basically P is an external point. From that point you need to find the equation of tangents to any of the two circles. किसी पे भी find कर लो. Because if it is going to touch S1, it will certainly touch S2 also in between, right? Or you can find tangents to S2, it will touch later S1 also, right? So now the question is, second step is, let slope of tangent is m. Okay, we have assumed the slope of tangent. Once we have written the tangent, then we know how to write the equation of tangent to this circle whose center is minus g minus f. Okay, do you remember that formula? Tangent in slope form. So equation of tangent is, third is writing the equation of tangent in slope form. Y minus y1, so y plus f is equal to m times of x plus g plus minus under root of r square, r you need to write r1 under root of 1 plus m square, or you can use the general equation and then length of OP is equal to r also you can do. Now you have written the equation in slope form. Now this tangent is passing through. Now this tangent is passing through from this point x1 y1. So put x1 y1 in this. Put x1 y1 in this. and then square and make a quadratic in m, we'll get two values of m. So y1 plus f minus m times of x1 plus g, all right, the whole square, squaring, and you'll get r square 1 plus m square. Here you'll get two values of slopes m1 and m2. It's a quadratic in m. You'll get two values, and then finally you can write tangents. Tangents are going to be y, tangents passing through this point, and of slope m1 and m2, all right. So lines, you need to write the equation of two lines. Y minus y1 is equal to m1 x minus x1. This is first tangent, and second tangent is y minus y1 is equal to m2 x minus x1. Okay, these are tangents. You got the procedure? Now we got the procedure. Got it now? So this is the procedure. Now tell me how to find transverse tangent. What is the difference? Everything is same. There's only one difference. Only one difference. The point P will be between the circles, right? If you draw this transverse tangent, this tangent is, these tangents are going to intersect between the circles, right? So then this point P was actually P was dividing this. Now you can see again these two circles are, again these two triangles are, I mean, this is R1 and this is R2, this is C1 and this is C2, and now P is here, right? Point of intersection. And of course P will lie on the line joining C1 and C2. Yes, now this P will bisect C1 and C2 internally. Again, these two triangles are similar triangles, PAC1 and PBC2. Now, and PC1 upon PC2 is same, R1 upon R2. In this case, if you assume these coordinates x1, y1, then x1 is going to be R1 into minus G2, and this will be plus only, right? Okay, in the previous example, in the previous case, it was minus because that was external division. Now this is internal division, so it will be R2 into minus E1. That is the only difference, and everything is same. Everything is same means rest of the procedure is same. Now you'll assume the slope, you'll put this point, and everything is same, right? So have you got it? Yeah. Now the second step is same. Let slope is m. Let slope of tangent. You know. So are you understanding this thing? That there's only one difference, internal and external. Once you have got this point, then it is just a question that you need to find the equation of tangents from an external point to any of the tangents. All right. So this is going to happen. Now I'll give you one example. You need to find the equation of tangents. So the first circle is x square plus y square. I'm giving you easy case. X square plus y square is equal to 16. And the second case is x minus 8 the whole square plus y square is equal to 4. All right. Find the equation of direct common tangent and transverse common tangent for this circle. Okay, let's do this. So have you got the point? Point of intersection of direct common tangents? Tell me the coordinates once you get it. Coordinates of P. 16 by 3. Alright. This is 0, 0. This is 8, comma 0. This radius is 2. This radius is 4. So it is dividing in 1:2 ratio, right? So 4 into 8. 4 into 8 minus 2 into 0 divided by 4 minus 2. Oh, so why are you getting 16 by 3? Huh? It is not 16 by 3, it is 16 only. 16. And 4 into 0, that will be 0 only. Y coordinate is going to be 0. 4 into 0 minus 2 into 0 upon 4 minus 2. So this is x1 and y1 is this. y1 is 0. This point is 16, comma 0. Transverse, okay. Yeah, this is called direct. So in direct it will be 16, comma 0. This is direct common tangent, okay. Okay. For transverse that will be, yeah, okay. So let's do it for direct, okay. We have got this point. Now remove this common tangent concept. Now we need to find the tangent to this circle. Choose one of the circle, whichever looks good to you. So of course we'll choose a standard circle, right? So we are going to choose this circle, x square plus y square. So if one of the circle is a standard circle, then always select that. Calculation will be slightly smaller, less. So this point is 16, comma 0. We need to find the tangents to the circle from 16, comma 0. That is our question, right? So let slope is m. So equation is y is equal to mx plus or minus whatever you want to take. Radius is 4 of this circle and 1 plus m square. Now this tangent is passing through 16, comma 0. So if you put 16, comma 0, so it is going to be 0 minus 16m is equal to 4 times of under root of 1 plus m square. Now you can see this 4 and this will get cancelled. 1 minute. 16, comma 0, and then I'm putting y minus 1 mx plus a under root of 16, comma 0. So 16m is equal to, yeah, so I'm getting 4m is equal to under root of 1 plus m square. Alright, squaring both the sides, I'll get 16m square. This is minus, by the way. 16m square is equal to 1 plus m square. So the values we are getting irrational, that doesn't matter. So it is m is equal to 1 plus minus of 1 upon root 15, right? Yeah. These are the values of slopes. Now you can write the equation of tangents. Basically, you need to write the equation of these lines which are passing through 16, comma 0. So y minus 0 is equal to plus minus of 1 upon root 15 into x minus 16. All right. Answers. What are you getting? Are you getting these values for transverse common tangents, Raghav? Okay. I am writing the tangent. Are you clear with? Yeah. Okay. All right. 1 upon root plus minus root 15 for direct. Alright, so now you understood the process, right? So this is the way to find the equation of common tangents. Alright. Direct and transverse, yes, both are done. Now see, a few more formula, let's finish. If tangents are, what is the equation of common chord? What is the equation if two circles are intersecting each other? Then this line, what is the equation of common chord? You know, this is a curve passing through the points of intersection of S1 and S2. So using family of curves, which I have told you in the previous sessions, S1 plus lambda S2 is equal to 0. The circle is S1 is equal to 0. And the second circle is S2 is equal to 0. And S1 plus lambda S2 always represents a curve which passes through the points of intersection of S1 and S2 if they are intersecting, right? So if S1 and S2 are intersecting, then there's a line also which passes through the points of intersection. And if you take lambda is equal to, minus 1, then S1 minus S2 becomes a line, right? Because x square, y square wale terms will get cancelled. So S1 minus S2 becomes a line. If you take lambda is equal to minus 1, yeah, you know that? Yeah, so if S1 is this, x square plus y square plus 2g1x plus 2f1y plus c1 is equal to 0. And S2 is this, x square plus y square plus 2g2x plus 2f2y plus c2 is equal to 0. So S1 minus S2 represents, so S1 minus S2. See this, S1 minus S2 is nothing but 2 times of G1 minus G2 into X plus 2 times of F1 minus F2 into Y plus C1 minus C2 actually. So it is a line, right? And because any combination of S1 and S2, whether it is S1 plus S2 or S1 plus 2S2 or S1 minus 3S2, it will be a curve passing through the points of intersection of S1 and S2, right? So this curve will also pass, and this is a line, so there can be only one line, and that line is called common chord. So this is the equation of common chord, all right? So we know now we have got you understood? Okay, you didn't get minus 1, okay? That's what I was trying to explain actually. Now listen to me again. Why this is a rule, okay? I started with proper explanation. You were not, I think you were not focusing on this thing. Now listen to this. You know, any two curves which will intersect at 2 points, A and B, say this is S1 and this is S2. Then S1 plus lambda S2 is equal to 0 will represent a curve passing through the points of intersection of S1 and S2. Right? This is the concept of family of curves passing through the points of intersection of two intersecting curves. Are you understanding this thing? I explained this concept when I was teaching family of curves during family of lines. When you write S1 plus lambda S2, it represents a curve passing through the points of intersection of S1 and S2. Now that curve can be anything. It can be a circle, it can be for some value of lambda, it can be circle. For other value of lambda, it might be a parabola. For different value of lambda, it might be a line. Okay. So if for some value of lambda, we are getting a line, there can be only one line, right? Because line there will be unique. There might be two circles passing through A and B. There might be infinite circles passing through A and B. But there will be only one line passing through A and B, a unique line. Are you understanding this thing? So that means there will be exactly one value of lambda for which this S1 plus lambda S2 will give you a line. And that unique value of lambda is nothing but minus 1, because when as you put lambda is equal to minus 1, this S1 minus S2 becomes a line. And what this line will represent? This will represent a line passing through their points of intersection. Okay. That's why we use lambda is equal to minus 1. If you want to use lambda is equal to minus 1, it will never become a line. It never becomes a line. It will be a circle only. In case of circles, if you're adding two circles, S1 plus lambda S2, and lambda is not minus 1, it will always be a circle actually. It will always be a circle. That's why we call it family of circles. But lambda is not minus 1. But if lambda is minus 1, it becomes a line, and that line is common chord. So now I think you are understanding it, okay? Now if circles touch each other, so I was coming back to this point in this case, because we have done direct common tangents and transverse common tangent. Now we need to do internal common. This is called internal common tangent at their point of contact. Okay, when circles touch each other, then this is their common tangent at their point of contact. What is the equation of this tangent? This is also S1 minus S2, right? This is the similar case like this. S1 minus S2 will be a curve which will always pass through all the points of intersection of S1 and S2. Now S1 and S2 are meeting only at one point. So this S1 minus S2 will also pass through exactly, from the same point. Yeah. Yes. So this is the equation of common tangent. Now suppose circles are like this. One circle touches the other internally. Then also equation of common tangent will remain same. Okay, equation will remain same. This tangent will be represented by S1 minus S2 is equal to 0. All right. So I hope now all these things are clear. So we have got equations of all types of common tangents. Okay, in all the scenarios. We have also understood the equation of common chord if circles cut each other at two distinct points. Are you understanding it, Raghav? All right. Just a moment. I'm giving you a few questions and then we'll continue next session. Just a moment. So we have done a lot of theory. Now let's do some questions. So I'm going to keep practice sessions also. What time would you be free? What time can you attend the practice session in the special classes? Today we have a practice session of straight lines. We'll discuss pair of straight lines mostly. And then probably by the end of this week, I will keep some sessions of circles also. Okay. So the common chord of x square plus y square minus 4x minus 4y is equal to 0 and x square plus y square is equal to 16 subtends at the origin an angle equal to, okay, and these are the options: pi by 6, pi by 4, pi by 3, pi by 2. So this is a question we are going to. The common chord of x square plus y square minus 4x minus 4y is equal to 0 and x square plus y square is equal to 16 subtends an angle at 0, 0. So origin पे what angle the common chord of these two circles subtends. Okay, this is a question. Try this one. Hello. Buhanuddin. Which center of pace? Borivali? Andheri? D? Are you getting D? Alright. OD2. Oh, the other. Okay. How are you? Syllabus done, huh? Exam is closed. How's your preparation? Syllabus कर लिया अच्छे से? It was due to the situation, nothing else. Bhavesh, today is not doubt session. Today is a practice session of straight lines. Okay, so this is the first circle of radius 4, and the other circle. What is the radius of the other circle? This other circle is basically passing through. Other circle is basically passing through 0, 0, right? It is like this. Oh, okay. So the radius of first circle is 4, and center is 0, 0, and radius of this other circle is center is 2, 2, which is actually inside the circle, and radius of this circle is under root of g square, so 4 plus 4, and c is not there, so it is actually 2 root 2, right? So 2 root 2 is the radius, 2 root 2. So if you plot this circle, it is going to be like this, something like this. Okay. So if you write the equation of common chord, what is the equation of common chord? Equation of common chord. Syllabus हो गया तुम्हारा? Buhanuddin. So it is 4x plus 4y, okay, is equal to 0. Now you can see 4x plus 4y is equal to 0. 4x plus 4y is equal to 6. What is this? 4x plus 4y minus 16, no? Plus 16 is equal to 16. I think it will be is equal to 16, yeah. So it is x plus y is equal to 4 actually. X plus y is equal to 4, you know? X plus y is equal to 4 is nothing but it is going to pass through these points, right? It is going to pass through these points. So these two circles are basically intersecting at the coordinate axis, right? Physics pending है, all right, अच्छा. Early start is compulsion, not what, Bhavesh? What are you saying? So now you can see this chord is subtending 90 degree, right? This is the angle basically. So angle is 90 degree. Is this clear to everyone? Raghav, Bhavesh, the motivational speaker. He comes up with some lines, copy and paste. All right. Oh guys, have you got this question? समझ आ गया ना? Geometrically we can understand that common chord is basically passing through these points, where this first circle First circle cuts at A and B, cuts the coordinate axis at A and B. This common chord is also passing through A and B. That means the second circle will also pass through this A and B. So this the common chord is subtending angle 90 degree at the origin, right? It is clearly visible. Mathematically देखना हो so then in that case what you will do, first you'll write the equation of common chord, okay, and any point, suppose this is the origin, okay. So there are many methods. You can homogenize one of the circle with common chord, because maybe origin is not center of any of the circles, okay. So what you need to do, you pick one of the circle, you pick the common chord, you know how to write the equation of common chord. Then what you need to do, homogenize this circle with this line. So after homogenizing, you'll get this pair of straight lines, equation of pair of straight lines, these two lines, right? 2-degree homogeneous equation. Are you understanding? This is common chord. This is one circle or any other curve. Then homogenize circle with common chord, you'll get the equation of combined equation of this pair. Then apply that formula, tan theta is equal to 2 under root of h square minus ab upon a plus b, alright? Once you get this pair of line 1 and 2. Now understood? So then this method you need to use in this case. I mean in general case you need to use this method. Whenever two curves are intersecting, two circles are intersecting, or maybe parabola, two parabolas, or a parabola or circle, and the common chord is they ask what angle common chord subtends at origin. This is very important. So when you see the common chord subtends at origin, that means you need to homogenize that curve, okay. But in case of circles we use geometry also. In case of circles we generally use geometry, because origin in this case is center of one of the circles. If it would have been center, then for homogenization would have been a better method. All right. Bhuvanadi, this is for actually class 11. This is not class 11. Basically, I'm covering the theory, which you have already done, I think. So if you want me to cover some topics, then you can ask me. I can take that topic in special classes, okay? Because the special classes, anyone can attend. So you can come and join my special classes whenever you need some help, all right? You just let me know which topic do you want to practice with me. So I'll plan that, okay, for you also. All right. Okay, Naga, then see you tomorrow. The remaining part of remaining theory, not tomorrow actually, maybe after 2 days. Okay, maybe after 2 days, because I'll be traveling. What is this peripecope? What is this? What have you written this? What do you mean by Raghav? How is calculus? I mean, you want to practice calculus? Oh, okay. I don't know. No idea. Why are you solving these books? The second one is yes, I have seen, but I don't think now this is the time for you to solve these books. This is the time for class 11th students. They should start. They have a lot of time, so they should do practice problems, because now you should be selective. You should be selective. I mean, the type of questions which they ask in JEE main. Revision of ellipse, parabola, hyperbola, circle combined session. Okay. I'll plan sessions. Okay, but not on YouTube. I'll plan sessions on special classes. All right, so you can come there on an academy. Special class, I know you must be knowing, right? Yeah, important concepts. Okay, I got your point. You need some special classes on coordinate geometry. All right. So be in touch. I'll plan you. I'll plan according to you. Okay. Just be in touch. You have my number. Okay. All right. All right. चलो फिर, all right राघव, all right everyone, all right, चलो चलो चलो, all right, see you soon, take care, bye bye.